long time, and I played around with it in GeoGebra and tried to figure out, different claims that I could make from this. So if you want to read through my claim that I ended up making, it's here at the top of this document. For all trapezoids with 3 of the 4 sides having the same length, and where the 4th side twice the length of any other side, which is what this reflect is asking you to think about, I said the internal angle measurements will be 60, 60, 120, and 120. So David talked about meeting the conditions of your claim as you work through your reference, and then trying to prove what the result is. So the conditions of this claim, if you read it, the conditions are that you have a trapezoid, or any trapezoid really, that 3 of the 4 sides have the same length, and the 4th side is twice the length of those other 3. So that's the conditions, and then the results that I'm trying to prove is these internal angle measurements. So I have a few minutes. I'll kind of walk you through part of this in GeoGebra, and hopefully this too will help you see some other features you can do. So I'm just going to start with a line segment, AB. And I thought about this, so I need to make 3 line segments that are the same length. So from here, I can go ahead, we talked about earlier too, tonight in this class, where the radii of any circle are the same length. And this is the mathematical property you should know. So I can use a compass, select my radius and my center of my circle, create another point on the circle, and make a segment. So I know, because this is a circle here, kind of off the screen a little, but I know that AB will be congruent to AC. And if I go ahead, change this, and turn off my circle, you can see that as I change my length of AB, my length of AC changes with it. And I can go ahead and swing AC wherever I need it to be. So I'm going to do that again, make another one. I'm going to center it at B, make a point here, a line segment here, turn off the circle. So now I have 3 sides that are all the same length, and they can change, with each other. To make a 4th side, I know that it has to be parallel to this side, and I also said, because that's the definition of trapezoid, and I know that it must be twice the length of this side. So to go ahead and do that, first of all, I'm just going to do it similarly to what I did before. Go ahead and do it this way. But I want it to hinge off this point down here. There we go. Let's make a point on the circle and create a line segment. Turn the circle off so I don't have all that garbage. Okay, and then I would know that I want it to be twice the length. So to make it something twice the length, you can reflect over it. So let's reflect about the point. You reflect this segment about this point. There we go. So now I have 3